We have spent the last century building the most precise picture of the universe ever assembled. The instruments took decades to design. The mathematics took generations to develop. The goal was simple: map everything that exists, measure how it moves, and understand what it all adds up to. We thought we knew the shape of the answer. We expected a universe we could, at least in principle, describe. A universe with a size. A universe with a story we could follow from beginning to end. But that is not what the evidence shows. The deeper we look, the further our telescopes reach. The more precisely our instruments measure. The more the universe resists the one thing we wanted most from it. A boundary, an edge, a number we could point to and say, this is the size of everything that exists. Instead, what the data returns every time from every instrument in every direction is a universe that does not stop. And a universe that does not stop does not simply mean a very large universe. It means something so much stranger that the mathematics required to describe it breaks every intuition you have ever had about what it means to exist. Because if the universe is truly infinite, and the evidence is stacking in that direction, then you are not a person. You are a pattern, a specific arrangement of matter that the universe, given enough space, is mathematically required to repeat. Not once, not 1,000 times, infinitely. There is another version of you right now in a region of space you will never see, watching this video. And that copy has no idea it is a copy, just like you. If you enjoy journeys that completely reshape how you see the universe, do me a small favor and hit that like button and subscribe. It genuinely helps this channel grow and lets me keep making these deep dives for you. Make yourself comfortable as we work through what an infinite universe actually means for you. Let us begin. What I am about to walk you through is not a list of speculations. It is not a collection of science fiction scenarios dressed up as cosmology. Every layer we will descend through is grounded in peer-reviewed physics. Every claim is traceable to a named scientist, a dated paper, or a confirmed observation. The mathematics is real. The measurements are real. The implications are real. And they are, in my honest assessment, the most disturbing set of implications that any branch of science has ever produced. Not because they describe a danger. There is no asteroid heading for Earth in this video. No gamma-ray burst aimed at your neighborhood. The danger here is subtler and in some ways more total. It is the danger that the universe is not what you think it is, and that you, specifically, are not what you think you are. Before we go any further, I want you to understand what infinity actually means. Not the mathematical symbol, not the vague sense of something very large, the operational reality of it. Infinity is not a big number. It is not a trillion. It is not a googolplex. It is not the number of atoms in the observable universe. All of those are finite. Infinity is the quality of having no end, no boundary, no final digit. No matter how far you go, there is further to go. No matter how many things you count, there are more to count. Infinity is not a destination you can approach. It is the discovery that there is no destination. The road goes on. The road always goes on. And everything that can happen on the road will happen on the road. because the road never runs out of distance. That is what we are about to apply to the universe and to you. We are going to work through 8 layers of this paradox. 8 ways the infinite universe breaks what you think you know about space, about matter, about identity, and about what it means to be you. Specifically, in a cosmos that may contain infinite versions of everything that has ever existed. Each one is worse than the last, and the last one has no clean answer. But before we can descend into what infinity does to the concept of you, we need to start with something simpler. Something you can verify yourself tonight just by looking up. Because the first crack in our understanding of the universe's size was not discovered by a telescope or a particle accelerator. It was discovered by a question so simple that it embarrassed astronomers for 2 centuries. In 1823, a German astronomer named Heinrich Wilhelm Olbers published a deceptively straightforward problem. The question had been circulating since at least 1610, when Johannes Kepler first raised it in a letter. But Olbers framed it in a form that would haunt cosmology for the next 200 years. The question was this: if the universe is infinite and filled with an infinite number of stars, why is the night sky dark? Think about the logic here. If stars go on forever in every direction, then every line of sight you draw from your eye outward into space must eventually land on the surface of a star. Not might, must. The same way that every line of sight through an infinite forest must eventually hit a tree trunk, no matter which direction you look. An infinite forest has no gaps. You cannot see through it. Every direction terminates at bark. Let me extend the analogy further, because the intuition matters here. You are standing in a forest. The trees are dense. You look north. You see trees, and behind them more trees. And behind those, still more trees, stretching to the limit of visibility. Everywhere you turn, in every direction, you see trunks and branches and leaves. No horizon is visible. No gap appears. The density of the forest guarantees that every line of sight terminates at wood. Now imagine the forest is infinitely large, and imagine every tree is glowing. Every trunk, every branch, every leaf is radiating light outward in every direction. In such a forest, there is no shadow, there is no darkness. The forest is a blinding wall of light from every angle. That is what an infinite, eternal universe of stars should look like from the inside. A wall of light in every direction. The entire sky should be as bright as the surface of a star, but it is not. You can walk outside right now and see darkness between the stars. Great swaths of it. The forest, it turns out, is not infinite and eternal in the way the question assumed. And the reason it is not tells you something profound about the nature of the cosmos you are living inside. An infinite universe of stars has no gaps either. Every square degree of sky should be blazing with starlight. The entire night sky should glow brighter than the surface of the sun, not in one direction, in every direction. You should not be able to find a single dark patch anywhere, because behind every dark patch, farther away, there is another star, and behind that star another, and behind that another, stretching outward without end. But you can look up tonight and see darkness between the stars. Lots of it. Most of the sky is dark. That darkness is not nothing. That darkness is data. Olbers knew this was a problem. A universe that is both infinite and eternal and filled with stars cannot produce a dark night sky. The darkness is a clue. It is physical evidence written across the ceiling of your world every single night, telling you that something about the assumptions does not add up. Either the universe is not infinite, or it is not eternal, or the stars are not uniformly distributed, or something else is happening that prevents the accumulated light of an infinite number of stars from reaching your eyes. The resolution came in the 20th century, and it did not make the problem smaller. It made it far stranger. The night sky is dark, not because the universe is small. It is dark because the universe has a finite age. Light travels at a fixed speed, roughly 299,792 kilometers per second. Fast, but not infinite. The universe is approximately 13.8 billion years old. That means the farthest light can have traveled since the Big Bang is 13.8 billion light years, adjusted for the expansion of space itself, which stretches the distance to roughly 46.5 billion light years in every direction. This defines the observable universe. A sphere centered on you with a radius of 46.5 billion light years, containing every photon that has had time to reach your position since the beginning of time. Beyond that sphere, more stars may burn, more galaxies may spin, more light may be traveling toward you at this very moment, but it has not arrived yet. Some of it never will. This has a secondary implication that is equally important. The darkness between the stars is not just a clue about the universe's age. It is a clue about its geometry. The fact that the cosmic microwave background, the oldest light in the universe, arrives from every direction with a temperature of 2.725. Kelvin tells us that the early universe was remarkably uniform, almost perfectly smooth. This uniformity is itself a puzzle. Regions of the early universe that are now on opposite sides of our sky, separated by 93 billion light years, show almost identical temperatures. But those regions were never in causal contact. They had no way to exchange energy and equalize their temperatures because they were already too far apart for light to travel between them in the time available. How did they end up the same temperature? The answer, proposed by physicist Alan Guth in 1980, is cosmic inflation, a period of exponentially rapid expansion in the first fraction of a second after the Big Bang, during which a tiny causally connected patch of space was stretched to a size vastly larger than the observable universe. The uniformity we see today is not a coincidence. It is a fossil of a moment when everything we can observe was once packed into a region small enough for its temperature to equalize. And the inflation that stretched that patch also stretched space itself far beyond what we can see, creating the conditions for a universe that may extend infinitely beyond our horizon. The darkness between the stars is not emptiness. It is a temporal wall, a boundary defined not by where space ends, but by how far light has traveled since the universe began. And here is the critical point that most people miss entirely. The observable universe is not the universe. It is the universe you are allowed to see. The darkness of the night sky does not prove the universe is finite. It proves the universe has a finite age. And what lies beyond the edge of the light is where the real paradox begins. That brings us to layer 1 of 8. The observable universe is not the universe. Most people, when they hear the number 93 billion light years, which is the diameter of the observable universe, hear it as the size of the cosmos. It feels like an answer. It feels like a boundary, the edge of the map, the limit of everything. And that feeling is completely, demonstrably wrong. The observable universe is a bubble, your bubble. It is defined by your position in space and the age of the universe. An observer sitting in a galaxy 10 billion light years from here has their own observable universe, also 93 billion light years across, centered on their location. Their bubble overlaps with yours, but also extends beyond it in directions you will never see. The universe does not have one observable horizon. It has as many horizons as there are observers, each one a private window into the cosmos. None of them seeing the whole. Now here is where the numbers become difficult to hold in your mind. But you need to hold them because what follows depends on understanding the scale. If the universe is spatially flat, which every measurement we have indicates it is to a precision of at least 99.6% according to data from the Planck satellite, then it does not curve back on itself. It does not wrap around like the surface of a sphere, where you can walk in one direction and end up where you started. A flat universe either extends infinitely or it is finite but unbounded in some exotic topological way that we have no evidence for. The simplest reading of the data, the one that requires the fewest additional assumptions, is that the universe is infinite. And if inflation theory is correct, which the cosmic microwave background data strongly supports, then the total universe is at minimum vastly larger than the observable portion. How much larger? Conservative estimates from flatness measurements suggest the universe is at least 250 times the diameter of the observable portion, or roughly 7 trillion light years across. Other calculations, based on the physics of the inflationary expansion itself, place the total universe at roughly 10 to the 23rd power times larger than what we can see. That is 100 sextillion. The observable universe, in this framing, is not a modest fraction of the whole. It is a rounding error. A speck inside a volume so large that calling it large is itself a failure of language. To feel this disproportion in your body, try the following. Imagine the observable universe, all 93 billion light years of it, shrunk to the size of a single grain of sand. That grain contains every galaxy, every star, every planet, every person who has ever lived, every photon that has ever been detected by any telescope ever built. Now imagine the total universe at the conservative lower bound, 250 times the diameter. Your grain of sand would be sitting inside a beach ball. Everything humanity has ever observed or could ever observe about the cosmos fits inside one grain of sand inside that ball. Now, imagine the inflationary upper estimate, 10 to the 23rd times larger. Your grain of sand would be sitting inside a volume so large that no comparison works. The observable universe, the thing we built the James Webb Space Telescope to photograph, the thing we have spent centuries studying, is smaller relative to the possible total universe than a single atom is relative to the entire Earth. And the total universe might be infinite, in which case the grain of sand vanishes entirely into a structure that has no edge to compare it to. Every photograph of the cosmos you have ever seen, every Hubble Deep Field, every James Webb mosaic, every panoramic map of the cosmic web is not a photograph of the universe. It is a photograph taken from inside the universe, showing only what light has had time to reach the camera. The universe is not in the photograph. The photograph is inside the universe. Now ask yourself what it means to build an entire science on observations from inside that grain of sand. Cosmology is the study of the universe, but we have only ever observed the universe from inside one infinitesimal corner of it. We assumed that corner was representative. We assumed the physics here is the physics everywhere. We assumed the density of matter here, the rate of expansion here, the distribution of galaxies here, mirrors the distribution everywhere. This is called the cosmological principle. It is the assumption that the universe looks roughly the same from every vantage point. And it may be true, but we cannot verify it. We cannot travel to a point 1 trillion light years away and check whether the cosmological principle holds there. We cannot send a probe beyond the observable horizon and ask it to report back. The assumption is necessary for cosmology to function, and it is untestable. This is not a minor philosophical caveat. This is the load-bearing wall of the entire building. If the cosmological principle is wrong, if the universe is significantly different beyond our horizon, then everything we have concluded about its age, its composition, its geometry, and its fate could be the local answer, not the global one. We would be like a fish in a pond, concluding that the entire world is water. Think about what this means for you, right now, sitting in this room. You are inside a bubble of visibility that is, at best, a microscopic fraction of all that exists. Every theory of physics you have ever been taught was built on observations made from inside this bubble. Every conclusion about the nature of reality was drawn from evidence gathered within this keyhole. We are making sweeping claims about the structure of the cosmos, based on the equivalent of a single cell scraped from the surface of a body we have never seen whole. There is an even more unsettling way to think about this. We are not just inside a bubble. We are inside a bubble that is getting less informative with every passing year. The accelerating expansion of the universe means that galaxies near the edge of our observable horizon are being redshifted, their light stretched to longer and longer wavelengths. As the wavelength stretches, the light carries less energy, less information per photon. The further we look, the dimmer and more degraded the signal becomes. Even the light that is still arriving is arriving in a diminished form. We are not just limited by the horizon. We are limited by the degradation of everything approaching the horizon. The universe is not merely hiding its secrets behind a wall, it is whisper eroding the secrets that are still on our side of the wall. Every photon that crosses the threshold from high redshift to ultra-high redshift, carries a little less clarity, a little less detail, a little less truth. Our picture of the cosmos is not just incomplete, it is actively deteriorating, and we are treating the cell as though it is the body. Every conclusion in cosmology rests on the assumption that what we see from here is representative of what exists everywhere. If it is not, then every conclusion carries an error we cannot measure because we cannot step outside the bubble to check. But here is where it gets stranger. Because the size of the universe is not just a measurement problem, it is a physics problem. And the physics right now is broken. That was layer 1. Layer 2 of 8, the Hubble tension. Our model of the universe is wrong. For the past decade, a crisis has been building inside cosmology that most people outside the field have never heard of. It is called the Hubble tension. And in January 2025, at a meeting of the American Astronomical Society, astrophysicist Dan Skolnick of Duke University declared that the tension was now a crisis. He was not exaggerating. The Hubble tension is a disagreement between two methods of measuring how fast the universe is expanding. The universe is expanding. We have known this since Edwin Hubble demonstrated it in 1929. Space itself is stretching, carrying galaxies apart from one another at a rate that increases with distance. The rate of this expansion is described by a single number. The Hubble constant, measured in kilometers per second per megaparsec. A megaparsec is 3.26 million light years. Think of it as a cosmic yardstick. The Hubble constant tells you how much faster a galaxy is moving away from you for every megaparsec of distance between you and it. Two independent methods exist to measure this number, and they should agree. They do not. The first method uses the cosmic microwave background, the afterglow of the Big Bang, captured with extraordinary precision by the European Space Agency's Planck satellite. This is the oldest light in the universe. It has been traveling for 13.8 billion years. By studying the patterns in this ancient radiation and applying the standard model of cosmology, physicists can predict what the expansion rate should be today. This method gives a value of approximately 67.4 kilometers per second per megaparsec. The second method measures the expansion directly, using nearby stars and supernova explosions as distance markers. Pulsating stars called Cepheid variables serve as the first rung of a cosmic distance ladder. These stars breathe. They expand and contract rhythmically, and the speed of that rhythm tells you how bright the star truly is. If you know how bright it truly is, and you can see how bright it appears from Earth, you can calculate how far away it is. Simple geometry applied across cosmic distances. Using that calibrated distance, astronomers then measure the brightness of Type 1a supernovae in the same galaxies. A Type 1a supernova is a specific kind of exploding star that always reaches roughly the same peak luminosity. It is the cosmic equivalent of a standard candle. If you know its true brightness, and you can see its apparent brightness, you know its distance. This technique, refined over decades by teams led by Nobel laureate Adam Riess at Johns Hopkins University, gives a value of approximately 73 kilometers per second per megaparsec. 67 versus 73. The gap between these two numbers is approximately 8 to 9%. That may sound small, it is not. Both measurements are now so precise that the disagreement has reached a statistical significance of 5 sigma. That means there is less than a 1 in 3.5 million chance that the discrepancy is a random fluke. In particle physics, 5 sigma is the threshold for declaring a discovery. The Higgs boson was confirmed at 5 sigma. Gravitational waves were confirmed at 5 sigma. In cosmology, 5 sigma means something is fundamentally wrong with the model. Think of it like this. Imagine 2 doctors measuring your heart rate with 2 different instruments. One reads 67 beats per minute. The other reads 73. They have checked their instruments. They have recalibrated. They have brought in 2 more instruments each and gotten the same results. 6 instruments, 2 groups of 3, and the groups do not agree. In medicine, that gap would not be a rounding problem. It would be a symptom. It would mean something is happening inside the patient that neither instrument is capturing correctly. The universe's Hubble tension is a symptom. We do not yet know what it is a symptom of. In December 2024, Ries's team published the largest study yet using the James Webb Space Telescope to verify the measurements made by the Hubble telescope. They used 3 different methods to measure distances to galaxies that hosted supernovae, covering roughly a third of Hubble's full galaxy sample. The result was unambiguous. Webb's data aligned closely with Hubble's measurements, yielding a Hubble constant of 72.6 kilometers per second per megaparsec, nearly identical to Hubble's 72.8 for the very same galaxies. The disagreement with the Planck value is real. It is not going away. As Ries stated, the discrepancy between the observed expansion rate of the universe and the predictions of the Standard Model suggests that our understanding of the universe may be incomplete. With 2 NASA flagship telescopes now confirming each other's findings, we must take this problem very seriously. And in early 2025, a separate study using gravitational lensing, an entirely independent measurement technique that does not rely on Cepheid stars or supernovae at all, confirmed the same picture. Researchers led by Tommaso Troi at UCLA used data from the Keck Observatory and JWST to measure the Hubble constant through a completely different physical process. Light from a distant quasar bends around a massive galaxy between us and the quasar. The amount of bending reveals the mass of the galaxy. The mass reveals the distance, and the distance reveals the expansion rate. Their value fell squarely in the range that deepens the tension. As Troi stated, what many scientists are hoping is that this may be the beginning of a new cosmological model. Now hold this in your mind. The Hubble constant is not just a number about how fast galaxies move apart. It is the backbone of cosmological calculation. The age of the universe is calculated from it. The size of the observable universe is calculated from it. The predicted locations of galaxies, the amount of dark energy, the geometry of space, the fate of the cosmos. All of these numbers are downstream of the Hubble constant. If the constant is wrong, or if our model is incomplete in a way that makes the constant context dependent, then every number in cosmology built on it carries an unknown error. It is like discovering that the ruler you used to build an entire city is slightly the wrong length. Every wall is off. Every floor is tilted. And you cannot tell which walls are wrong because you used the same ruler for all of them. There is additional evidence that makes this worse. In 2024 and 2025, the Dark Energy Spectroscopic Instrument, known as DESI, released results from its survey of baryon acoustic oscillations, the imprint of sound waves in the early universe preserved in the distribution of galaxies today. These measurements trace the expansion history of the cosmos across billions of years. DESI's results largely aligned with the Planck prediction, favoring a value near 68.5. But they also contained a tantalizing hint that dark energy might not be constant. It might be changing over time. If dark energy is evolving, the entire framework of lambda CDM, the model we have relied on for 2 decades, may need to be replaced. The Hubble tension would not be a bug in the model. It would be the first symptom of the model's obsolescence. What does this mean for you sitting right here? It means the most fundamental description of the universe we have. The model that tells us how old the cosmos is, how big it is, and what will happen to it, may be wrong in a way we have not yet identified. You are living in a universe whose instruction manual has a printing error we cannot find. Every page looks correct in isolation, but the pages contradict each other when you read them side by side. And we do not know which page to trust. But the broken model is not the terrifying part. What the broken model is pointing at, the possible reason for the disagreement is: that was layer 2, layer 3 of 8, the accelerating expansion. The universe is rushing toward isolation. To understand why the accelerating expansion is terrifying in a way that the broken model is not, you need to understand what acceleration means for the future of everything you can see. A decelerating universe is a universe that might eventually stop expanding, a universe that might contract, a universe that has a future where things come back together. An accelerating universe is a universe that is rushing toward separation, toward isolation, toward a future where every island of light drifts further from every other island of light, faster and faster, until the distance between them exceeds the capacity of any signal to cross it. An accelerating universe is a universe that is sentencing every civilization within it to eventual, total, permanent loneliness. Not as a distant possibility, as a mathematical certainty. In 1998, 2 independent teams of astronomers set out to measure something they were confident they already knew the answer to. They wanted to confirm that gravity was slowing the expansion of the universe down. The Big Bang sent everything flying apart. Gravity should be pulling it back together, like a ball thrown upward, gradually losing speed before it falls. They used Type 1a supernovae, those standard candles we just talked about, to measure distances to galaxies at different points in cosmic history. By comparing how fast those galaxies were moving away at different epochs, they could trace the deceleration curve. They expected to find a universe that was breaking, The results were the opposite of what they expected. The supernovae were fainter than predicted. They were farther away than they should have been. The expansion of the universe was not slowing down. It was speeding up. Something was pushing space apart faster and faster, overwhelming the gravitational attraction of all the matter in the cosmos. Saul Perlmutter, Brian Schmidt, and Adam Rees received the Nobel Prize in Physics in 2011 for this discovery. And the force responsible was given a name that reveals how little we understand it: dark energy. Dark energy constitutes roughly 68% of the total energy content of the universe. Think about that number for a moment. More than 2/3 of everything that exists is made of something we cannot see, cannot touch, cannot detect directly, and cannot explain. We do not know what dark energy is. We do not know where it comes from. We do not know whether it is constant or changing over time. We have no confirmed theory that explains its existence. It is the single largest component of the cosmos and the single least understood thing in all of physics. We named it the way you name a strange noise in the walls of your house. You call it the noise. It does not mean you know what is making it. Here is a way to feel dark energy in your own body. Right now, the atoms in your hand are held together by the electromagnetic force, which is strong enough to keep them bound across atomic distances. The gravity between the atoms in your hand and the atoms in the table beneath it is what keeps you from floating away. These forces operate at close range, and they dominate at close range. Dark energy operates at enormous scales. At the scale of your room, dark energy is unmeasurably weak. At the scale of a galaxy, it is still overwhelmed by gravity. But at the scale of the distances between galaxy clusters, dark energy wins. It wins because it does not dilute. As space expands, matter spreads thinner. Gravity weakens as objects separate. But the density of dark energy remains constant. Every new cubic meter of space that appears carries the same amount of dark energy as the previous one. This means that as the universe grows, gravity gets weaker, but dark energy stays the same. Over cosmic time, this is a race that dark energy always wins. Slowly at first, then faster, then overwhelmingly. The universe is in the grip of a force that does not weaken with distance and does not dilute with expansion. And that force is pushing everything apart. What we do know is what dark energy does. It causes space itself to expand at an accelerating rate. And the consequences of that acceleration are devastating. The farther away a galaxy is, the faster it recedes from us. Not because it is moving through space at high velocity, but because the space between us and it is stretching. The amount of stretching is proportional to the distance. Double the distance, double the recession speed. At some threshold, roughly 14.5 to 18 billion light years, depending on the calculation, the stretching becomes so extreme that the galaxy is receding faster than the speed of light. Not because it is violating Einstein's relativity. Objects cannot move through space faster than light. But space itself can expand at any rate it wants. And beyond that threshold, the gap between us and the galaxy grows faster than light can cross it. No signal we send will ever reach it. No signal it sends will ever reach us. It is gone, not temporarily, permanently. Now, here is where the numbers stop being abstract. Right now, today, approximately 94% of the galaxies within our observable universe are already beyond our reach. We can see them. Their ancient light is still arriving at our telescopes. But the galaxies themselves, as they exist right now, are already moving away faster than light. If you launched a probe today at the speed of light aimed at any galaxy beyond our local group, that probe would never arrive. The gap would grow faster. Then the probe could close it. You can see the galaxies. You just cannot get to them. They are ghosts on a screen showing you a movie of a universe that no longer exists in the form you are watching. According to astrophysicist Ethan Siegel's calculations, of the roughly 2 trillion galaxies in the observable universe, only about 6%, roughly 120 quintillion stars, are presently reachable. And every year, that number shrinks. Hundreds of millions of additional stars cross the threshold from reachable to unreachable annually. They slip from one column to the other silently, without any visible change. Their light continues to arrive. They appear unchanged in the telescope. But the galaxy that produced that light has already crossed the point of no return. You are watching the delayed broadcast of something that is already gone. Here is a number that makes this visceral. According to calculations by astrophysicist Ethan Siegel, roughly 160 billion stars per year are slipping beyond the cosmic event horizon. That is roughly 5,000 stars per second. While you have been listening to this sentence, approximately 20,000 stars have crossed the threshold from reachable to unreachable. They did not explode, they did not go dark. They are still burning. They may still have planets orbiting them, planets with atmospheres and weather and maybe even oceans. But the space between us and them just expanded past the critical threshold. The gap is now growing faster than light can cross it. Those stars and everything around them are now part of the permanently inaccessible universe, lost to us, not metaphorically, physically, by the laws of space-time that govern everything that exists. Now think about that from the other direction. If there are observers on one of those planets, observers with telescopes pointed at the Milky Way, they are watching our galaxy recede. They are watching our light stretch and dim. From their perspective, we are the ones vanishing. We are the ghosts. We are the after-image of a galaxy that has already moved beyond their reach. Both perspectives are equally valid. Both observers are real. Neither can do anything about the separation. The accelerating expansion is symmetrical. It is not happening to one side. It is happening to all sides, everywhere, all the time. And it gets worse with time. In approximately 1 billion years, the reachable fraction drops from 6% to 5%. After 150 billion years, every galaxy beyond our local group, the gravitationally bound cluster of roughly 50 galaxies that includes the Milky Way and Andromeda, will have crossed the cosmic horizon permanently. Think about what that future looks like from the inside. Any civilization existing 150 billion years from now will look out at a sky containing only the merged remnants of the Milky Way and Andromeda. One single mega-galaxy surrounded by a perfectly dark, perfectly empty void in every direction. No cosmic microwave background detectable, because it will have been stretched to wavelengths too long for any instrument to capture. No distant galaxies to study. No supernova standard candles to calibrate against. No way to measure the expansion rate, because there is nothing visible beyond the local island to recede. No way to determine the age of the universe, because the evidence has vanished. No way to reconstruct the Big Bang, because the radiation it left behind has been diluted below detection. An astronomer born into that cosmos would conclude reasonably and rationally that the universe consisted of a single galaxy surrounded by an infinite void. They would have no evidence to the contrary. They would construct theories that explained a single galaxy universe. They would be satisfied with those theories, and they would be completely wrong. The Big Bang happened. The trillions of galaxies existed. The cosmic microwave background carried the fingerprint of creation. All of it real, all of it gone, not destroyed. Simply pushed beyond the reach of evidence by the accelerating expansion of space. The universe is not just expanding. It is actively erasing the conditions under which its own truth can be discovered. We exist during the narrow window in which the evidence is still visible. That window is closing in real time, and we are inside it right now. The last generations of observers who will ever have access to the full cosmic picture. But if the universe is infinite, if it truly never ends, then the acceleration does something even more disturbing than isolate us. It makes the question of what fills the rest of that infinite space the most unsettling question in physics. That was layer 3, layer 4 of 8. The finite matter problem, infinity with a finite alphabet. Here is an assumption most people carry without realizing it. If the universe is infinite, it must contain infinite variety, infinite different things, infinite different arrangements, an inexhaustible library of novelty stretching outward in every direction without ever repeating itself. That assumption is wrong. The reason it is wrong begins with a fact about the physical world that sounds simple but has consequences that unfold for the rest of this video. Matter is made of a finite number of particle types. The standard model of particle physics identifies a specific set of fundamental particles, 6 types of quarks, 6 types of leptons, gauge bosons that carry the fundamental forces. The Higgs boson, confirmed at CERN in 2012. These combine into protons, neutrons, and electrons, which combine into atoms, which combine into molecules. The alphabet of the physical universe is large, but it is finite. There are 118 confirmed elements. There is no 119th element hiding in a distant galaxy. The laws of physics are the same everywhere. We know this because we can see the same atomic spectra in galaxies billions of light years away, the same hydrogen emission lines, the same helium absorption patterns. The particle menu does not change with distance. The alphabet is universal and it is closed. Now here is the second fact. Any region of space the size of our observable universe can only contain a finite number of particles arranged in a finite number of ways. The observable universe contains roughly 10 to the 80 protons. That is a 1 followed by 80 zeros. Each of those positions in space can be either occupied or unoccupied by a particle. And each particle can be in one of a finite number of quantum states. This gives approximately 2 to the power of 10 to the 118th possible configurations. That is an almost incomprehensibly large number. Writing it in full would require more digits than there are atoms in the observable universe. But it is finite. It has an end. It is a very, very, very large number, but it is a number, not infinity. Now combine these two facts with a third. The universe may be infinite. Think about what happens when you combine infinite space with a finite number of possible arrangements. Imagine a deck of 52 cards. You shuffle it. The specific ordering you get is one of roughly 8 times 10 to the 67th possible sequences. That is a number larger than the number of atoms in the observable universe. The first time you shuffle, the order is almost certainly unique. Shuffle again. Unique again. Shuffle a billion times. Still probably unique. The number of possible orderings is so vast that repeating any previous arrangement by random chance takes an inconceivably long time. But it is not impossible. And if you shuffle forever, you must eventually repeat. You have to. The permutations are finite. And forever is not. The deck of the universe is far larger than 52 cards, but it is still a deck. And the universe, if it is infinite, provides an infinite number of shuffles. Max Tegmark, cosmologist at MIT, published a formal calculation on this in February 2003 in a paper submitted to our Ethics Arm titled Parallel Universes. Later featured as a cover story in Scientific American in May of the same year. He calculated the expected distance to the nearest exact copy of our entire observable universe. Not an approximate copy, an exact duplicate. Every galaxy in the same position, every star at the same stage of its life cycle, every planet with the same geology, the same atmosphere, the same distribution of continents and oceans. Every person in the same location doing the same thing. Every atom in the same quantum state. The distance he calculated was approximately 10 to the power of 10 to the 118th meters. That is a number that requires exponentiation to even write. You cannot reach it. You cannot conceptualize it. But it is a finite distance. A specific, calculable, peer-reviewed number in a reputable journal. And in an infinite universe, that is not the distance to the one copy. That is the distance to the nearest copy. Beyond it, infinitely more. Tegmark's paper included a detail that most summaries leave out. He calculated not just the distance to the nearest identical copy of a person, but the distance to the nearest identical Hubble volume. A region of space the same size as our observable universe, with every particle in every position, in every quantum state, perfectly duplicated. That distance is roughly 10 to the power of 10 to the 115th Hubble radii, or equivalently 10 to the power of 10 to the 118th meters. Beyond that distance, entire observable universes begin to repeat. Not just people, not just planets, not just galaxies. entire cosmic horizons, entire histories. Every event that has ever occurred within our bubble of visibility, duplicated in its totality in another bubble, somewhere in the infinite expanse, right now. This means the Big Bang, as we experienced it, has been experienced identically in other Hubble volumes. The same fluctuations in the cosmic microwave background, the same formation of the same galaxies in the same positions, the same Milky Way, the same solar system, the same Earth, the same evolution of life, the same development of civilization, the same construction of the same telescopes pointed at the same sky, detecting the same cosmic microwave background, drawing the same conclusions about the same universe. Every scientific discovery we have ever made has been made independently, identically, by copies of us in other Hubble volumes. Every philosophical question has been asked. Every answer has been given. This is not speculation. It is combinatorics. Your nearest identical copy as an individual person would be considerably closer, at roughly 10 to the power of 10 to the 29th meters. Still beyond comprehension, but finite. Tegmark himself noted that this number is likely an overestimate, because the processes of planet formation and biological evolution tip the odds in favor of producing copies much more often than pure random arrangement would suggest. The universe is not shuffling atoms at random. It is running the same physics everywhere. The same gravitational collapse, the same stellar nucleosynthesis, the same organic chemistry. Which means that the conditions that produced you are not unique conditions. They are standard conditions, and standard conditions, given infinite space, produce standard results infinitely many times. Think about what this means for you right now. You are a specific arrangement of roughly 7 octillion atoms. That is 7 followed by 27 zeros. That arrangement includes every synapse in your brain, every protein in your blood, every charge differential across every neural membrane. The specific thought you are having right now, the specific emotional state you are in, the specific pattern of light hitting your retinas from this screen. All of it is a physical configuration of matter. And in an infinite universe, that configuration is not unique. It is one instance of a pattern that the cosmos must produce infinitely many times, simply because it has infinite room and a finite number of ways to fill it. Here is a way to feel this in your body. Hold up your hand. Look at it. The carbon atoms in your skin were forged in a star that exploded before the sun was born. The iron in your blood was produced in the core of a dying giant. The calcium in your bones was scattered across a nebula by a supernova shockwave. Every atom in your hand arrived at this planet through a chain of events spanning billions of years. That chain, that specific sequence of stellar births and deaths, and gravitational collapses and chemical reactions, is a particular arrangement of matter, a specific shuffle of the cosmic deck. Now consider this. In an infinite universe running the same physics everywhere, that exact chain has occurred before, not something similar to it. That exact chain, the same star forming from the same molecular cloud at the same time in the same region of a galaxy with the same composition, the same supernova scattering the same elements into the same interstellar medium, the same solar system forming from that same material, the same planet, cooling at the same rate with the same oceans and the same geology and the same first replicating molecule in the same thermal vent. All the way forward through 4 billion years of evolution, to the exact moment when your hand formed in the exact shape it is right now. In an infinite universe, that chain is not a one-time event. It is a recurring theme, a melody the cosmos plays whenever the instrument is tuned correctly. And in an infinite cosmos, the instrument is always tuned correctly somewhere. The universe is a copy machine that never runs out of paper, and you are the document on the glass. But an exact copy of the observable universe is not the same thing as an exact copy of you. Not yet. To understand why the copies are truly disturbing, we need one more layer. And it is the one that breaks the concept of identity entirely. That was layer 4, layer 5 of 8. The Boltzmann brain, or the question you cannot answer. Are you the original? In the late 19th century, Austrian physicist Ludwig Boltzmann, one of the founders of statistical mechanics, confronted a problem so fundamental that it would take 100 years for the rest of physics to catch up with it. Boltzmann understood what randomness could produce given enough time. He knew that in a system governed by thermodynamics, thermal fluctuations, the random jostling of particles could occasionally produce organized structures purely by chance. Usually, those fluctuations are tiny and meaningless. A few gas molecules happen to cluster together for a fraction of a second before dispersing. But Boltzmann realized that if you gave the system enough time, if the shuffling went on long enough, the fluctuations could become large. Arbitrarily large. Organized enough to produce not just a cluster of molecules, but a galaxy. Not just a galaxy, but a brain. A fully functional human brain, complete with synaptic connections, encoding memories of a life it never lived, sensory impressions of a world that does not surround it, and the subjective conviction that it is a real person with a real history sitting in a real room. This is not science fiction. It is statistical mechanics applied to a universe with infinite time. The original insight came not from Boltzmann himself, but from the logical extension of his work by others over the following century. Boltzmann's concern was about the arrow of time. Why does time flow in one direction? Why does entropy, the measure of disorder, always increase? His answer was that the universe we observe is a fluctuation within a much larger, much older system that has already reached thermodynamic equilibrium. Our low entropy universe, with its structured galaxies and organized matter, is a temporary deviation from the norm. Given enough time, even the most improbable deviations will occur. But in 1931, astronomer Arthur Eddington pointed out the devastating corollary. If our entire observable universe is a fluctuation, then smaller fluctuations are exponentially more probable than larger ones. The smallest possible fluctuation that produces a conscious observer is not a full universe with galaxies and stars and planets and biology. It is a single brain, assembled with just enough structure to have one moment of coherent thought before dissolving back into chaos. By 2004, physicists, including Andreas Albrecht and Lorenzo Sorbo, had pushed this to its conclusion. In an eternal universe, the overwhelming majority of all conscious observers would be exactly these minimal fluctuations. Boltzmann brains. Not embedded in any universe. Not part of any biology. Just isolated pockets of momentary consciousness in an otherwise empty void. The concept was formalized in the early 2000s when physicists, including Sean Carroll at Caltech, Andreas Albrecht and Alan Guth, recognized that the Boltzmann brain problem was not a thought experiment. It was a crisis. Here is the mechanics of the problem. Our current best cosmological model, Lambda CDM, predicts that the universe will eventually be dominated by dark energy and enter a state called de Sitter space. De Sitter space is essentially empty space with a tiny but permanent positive cosmological constant. It is eternal, and it has a temperature, an extraordinarily low temperature, roughly 10 to the negative 29th Kelvin, but not zero. A non-zero temperature means thermal fluctuations. And given an eternity, any fluctuation that can happen will happen, including the spontaneous assembly of a conscious brain from particles that randomly find each other in the void. Here is why this is a crisis, not merely a curiosity. In an eternal universe, the number of normal observers, beings like you, who evolved through biological processes on real planets, is finite. Stars burn out, planets cool, biology ends. The production of normal observers stops after the stelliferous era ends. But Boltzmann brains are produced by vacuum fluctuations, and vacuum fluctuations continue for eternity. Over infinite time, infinitely many Boltzmann brains are produced. They outnumber normal observers by an infinite margin, which means that if you choose a conscious observer at random from all conscious observers that will ever exist, the probability that you chose a normal observer, a real biological person with genuine memories, is zero. Not small. Zero. The overwhelmingly likely answer is that you are a Boltzmann brain. A fluctuation that assembled itself from vacuum noise 5 seconds ago with a complete set of false memories, false perceptions, and a false conviction that it has lived an entire life. Carroll has argued in a 2017 paper titled "Why Boltzmann Brains Are Bad" that this is not merely an intellectual problem. It is a threat to the entire enterprise of science. If you cannot trust your memories, you cannot trust your observations. If you cannot trust your observations, you cannot do science. Any cosmological model that predicts Boltzmann brains dominate the senses of observers undermines the foundation on which it was built. The theory devours itself. Carroll argues that such models must be rejected, not because they are philosophically uncomfortable, but because they are cognitively unstable. A theory that predicts its own evidence, is unreliable, cannot be accepted on the basis of that evidence. And here is the part that sits with you after you close this video. There is no test you can perform right now to confirm you are not a Boltzmann brain. Every memory you have, your childhood, your family, your entire life up to this moment, could be a false pattern encoded in a brain that assembled itself from the vacuum 3 seconds ago. The room you are sitting in could be the first and only room you have ever experienced. The sense of time passing could be an artifact of synaptic configuration rather than a record of events. You cannot verify any of it from the inside. Because every tool of verification, your senses, your memories, your reasoning capacity, is itself part of the system whose reliability is in question. You are trying to use a potentially broken ruler to measure whether the ruler is broken. Now, sit with that for a moment. Really sit with it. The chair you are in, the temperature of the air on your skin, the weight of your body pressing downward, the specific quality of light in the room. All of it could be a 5-second-old fabrication assembled by chance from particles in a void. Your sense that time has been passing, that you woke up this morning, that you had breakfast, that you traveled to wherever you are right now. All of those memories are encoded in neural connections. And neural connections are physical structures. Physical structures that could, in principle, be assembled by a sufficiently large thermal fluctuation without any of those events actually occurring. This is not a question of faith or philosophy. This is a question of statistical mechanics. And the statistics say that in an eternal universe, the overwhelming majority of observers who believe they have a past did not actually have one. They are phantoms of the vacuum, convinced of their own reality by the very neural architecture that was supposed to guarantee it. Most physicists do not believe we are Boltzmann brains. Carroll's argument against them is widely respected. But the fact that the argument needs to be made at all, the fact that our best cosmological model produces this problem as a natural consequence of its own equations, tells you something about the kind of universe the equations are describing. It is a universe where the boundary between real and hallucinated is not as clear as your intuition insists. It is a universe where existence itself requires defense. But even setting Boltzmann brains aside, even granting that you are real and your memories are genuine, the infinite universe has one more thing to say about your identity. And it is the most personal violation of all. That was layer 5, layer 6 of 8. The infinite copies problem. You are not unique. If you are not a Boltzmann brain, if you are a genuine biological observer who evolved on a real planet orbiting a real star in a real galaxy, then the infinite universe has a different but equally disturbing implication. You are not the only version of you. You are one of infinitely many. In an infinite universe with finite particle types, there exist right now infinitely many exact physical copies of you. Not approximate copies, not people who look like you or share your name. Exact copies. Identical down to the quantum state of every particle in your body. Same neural configuration, same memories, same personality, same scar on your left knee from when you were 7. Same specific feeling you are having right now as these words arrive in your mind. The copy has every memory you have. It believes, with complete conviction, that it is the original. It would pass every test. It would recognize your mother. It would remember your passwords. It would finish your sentences. It is not a clone or a twin. It is you, assembled independently by the same physics, the same chemistry, the same evolutionary processes, in a different region of space, so far away that no signal could ever cross the distance between you. This is Techmark's Level 1 multiverse. And here is the part that physicists find most unsettling. It is not speculative. It is the direct, inescapable mathematical consequence of two premises that mainstream cosmology accepts. One, the universe is spatially infinite, or at least large enough to exhaust all possible configurations. Two, the number of possible quantum configurations within any observable volume region is finite. That is it. Those two premises together require the copies. No new physics needed. No extra dimensions. No exotic matter. No untested theories. Just arithmetic applied to infinity. Think about what this does to the concept of a decision. Every decision you have ever agonized over, every fork in the road, every moment where you chose one path and abandoned another is happening in infinite versions simultaneously. There are copies of you who made the other choice. Copies who said yes when you said no. Copies who stayed when you left. Copies who called when you did not. The universe contains every version of your life that could physically exist. All of them real. All of them convinced they are the original. None of them with any more claim to that word than any other. If you died right now, and one of those copies continued, it would not notice the substitution. It would go on living your life, your plans, your relationships, your unfinished conversations, with no sensation of discontinuity. Because its memories include this moment. Its memories include reading these words. It would remember dying no more and no less than you would remember its parallel existence. The question of which one is you has no physical answer. Physics does not distinguish between originals and copies when the copies are physically identical. Identity in an infinite universe is not a fact about the world. It is a story you tell about yourself from inside a particular arrangement of atoms. And that story is being told right now infinitely many times by infinitely many tellers, each one believing it is the only one telling it. Consider the teleporter paradox more carefully. In Star Trek, when Captain Kirk steps into the transporter, the device scans every atom in his body, records its position and quantum state, disassembles him at the origin, transmits the information to the destination, and reassembles him from local matter. The person who steps off the transporter pad believes he is Kirk. He remembers stepping on. He feels continuous with the person who entered. But is he? The original pattern was destroyed. A new one was built from the blueprint. If the transporter malfunctioned and left the original intact while also building the copy, two Kirks would exist. Both would claim to be real. Both would have equal evidence. Neither could be proven wrong. Now remove the transporter entirely. In an infinite universe, the copy was not built by a machine. It was built by the same physics, running independently, in a region of space so far away that no communication between original and copy is possible. The copy did not need your blueprint. It did not need your atoms. It needed only the same laws of physics, the same initial conditions, and enough space to produce the same result. And it has all three, infinitely. This means you are not one person with copies elsewhere. You are one instance of a pattern that the universe generates naturally, repeatedly, without effort, whenever the conditions permit, And in an infinite universe, the conditions always permitted somewhere. Your sense of being the original, the real one, the one true you, is indistinguishable from the sense every copy has. They all feel original. They all feel real. They all feel singular. That feeling is not evidence of uniqueness. It is a feature of the pattern itself. Every instance of the pattern includes the conviction that it is the only one. There is something else that happens when you sit with this idea long enough. The copies stop being a thought experiment and start being a presence. Not in a mystical sense, in a physical one. If you accept the premises, and mainstream cosmology does, then the copies are as real as you are. They are not potential beings. They are not hypothetical constructs. They are actual configurations of actual matter in actual regions of actual space, experiencing actual consciousness with actual subjective weight right now as you read this. They have names, they have families, they have unfinished business. They are worried about the same things you are worried about. They are hoping for the same things you are hoping for. They are afraid of the same things. And they do not know about you. You do not know about them. The causal disconnection of the cosmic horizon ensures that no version of you will ever confirm the existence of any other version. Each copy lives and dies in complete subjective isolation, unaware that the pattern it embodies has been repeated an infinite number of times across an infinite expanse. Each one grieves its losses as though they were the only losses. Each one celebrates its joys as though they were the only joys. Each one sits alone at 3 a.m, wondering whether any of it matters, not knowing that infinite other versions of itself are sitting in identical rooms at identical hours, wondering the identical thing. This is the paradox of the infinite universe stated at the most personal scale possible. You are alone and you are accompanied. You are unique and you are common. You are one and you are many. And you have no way to determine which of these descriptions is the correct one, because all of them are true simultaneously. The concepts themselves break down under the weight of infinity. The categories of alone and accompanied, unique and common, one and many, were designed for a finite world. In an infinite world, they overlap. They coexist. They mean opposite things at the same time. Now bring this into your body. The neurons in your brain are firing right now in a specific pattern. That pattern constitutes your experience of this moment. The feeling of the surface beneath you, the ambient sound around you, the particular quality of attention you are bringing to these words. That pattern is physical. It is electrochemical. It is a specific configuration of ions flowing through specific channels in specific cells arranged in a specific architecture of synaptic connections that were shaped by every experience you have ever had. That pattern is you in the most literal neurological sense. And that pattern in an infinite universe exists right now in another brain, in another skull, on another planet, in another galaxy, in another Hubble volume. That brain is having this exact experience. It is hearing these exact words and feeling the exact same quality of attention and sitting in the exact same posture and breathing at the exact same rate. It is you in every way that the word you has ever meant anything. The question, which is the real one, is not a question with an answer. It is a question that reveals the limits of the concept of real. In a universe where physical identity is the only identity, and where physical configurations repeat infinitely, the word real stops referring to a single thing and starts referring to a category. You are not a person. You are a type. And the type has infinite members. But the copies are not the worst version of this. Because the infinite universe does not just repeat you as you are right now. It repeats every version of you that could physically exist, including the versions you chose not to be. That was layer 6, layer 7 of 8. Poincaré recurrence. Every moment of your life repeats forever. In 1890, French mathematician Henri Poincaré proved a theorem that would haunt physics for more than a century. The Poincaré recurrences theorem states that any dynamical system with a finite number of possible states and bounded energy, given sufficient time, will return arbitrarily close to any previous state it has ever occupied. The proof is rigorous. The conclusion is exact. Given enough time, the configuration must repeat. Think about what this means in physical terms. A sealed room full of gas molecules is a bounded system. The molecules bounce around, collide, exchange energy, and continuously rearrange themselves. In the short term, the arrangement is chaotic. In the long term, it is predictable in one specific sense. Every arrangement the gas has ever been in will eventually be recreated down to the position and velocity of every molecule. Not approximately, arbitrarily close to exactly. The room will cycle through every possible state, including states it passed through moments after you first sealed it. How long does this take? For the molecules in a single room, the recurrence time is a number so large that it makes the age of the universe look like a rounding error. But the theorem does not say it will happen quickly. It says it will happen certainly. Given that the system persists, the recurrence is guaranteed. Now, extend this to the cosmos. If the universe has finite possible quantum states within any bounded region, which it does, and if time extends infinitely into the future, which the current cosmological model predicts under the assumption of a positive cosmological constant, then every configuration of matter that has ever existed within any finite volume of the universe will recur. Not once. Infinitely. Friedrich Nietzsche arrived at this conclusion philosophically in 1882, 8 years before Poincaré proved it mathematically. In The Gay Science, aphorism 341, Nietzsche imagined a demon who steals upon you in your loneliest loneliness and tells you that this life, as you now live it and have lived it, you will have to live once more and innumerable times more. Every pain and every joy and every thought and every sigh, everything unutterably small or great, all in the same succession and sequence, even this spider and this moonlight between the trees, and even this moment and I myself. He called it the greatest weight. The question he posed was not whether the recurrence is real. The question was whether you could bear it. Personally, I no longer believe the recurrence is merely a thought experiment. The premises are too clean. Finite states, infinite time. The conclusion follows with mathematical certainty if the premises hold. And both premises are, at present, supported by the best evidence we have. The universe has finite possible configurations within any finite volume, and the best cosmological model predicts a future that extends indefinitely. Whether the recurrence applies to the entire cosmos or only to bounded subsystems within it is an open question. But the question itself is enough to change how you think about a Tuesday afternoon. Because if Tuesday afternoon comes back, it comes back exactly with the same coffee, the same weather, the same conversation you had with a person you have not spoken to in years, the same regret, the same sudden, unexpected moment of beauty that you noticed and then forgot, which will now arrive again and be noticed again and be forgotten again, in a cycle that has no exit and no audience. Whether, hearing the demon's declaration, you would fall to the ground, gnashing your teeth and cursing the demon, or whether you would call it the most divine thing you had ever heard. Historians of statistical mechanics, including Stephen Brush, have treated Nietzsche as a qualitative anticipator of Poincaré's result. Both proceed from the same two premises. Finite states, infinite time. Both arrive at the same conclusion. Everything returns. The timing is nearly poetic. Poincaré's theorem was revealed to the world on January 21st, 1889, after winning King Oscar of Sweden's prize competition, with considerable media attention. Nietzsche's mental collapse occurred just weeks later, in early January 1889. With another month of lucidity, he might have learned that the mathematics of classical mechanics had confirmed the philosophical nightmare he had spent 7 years building. Now, here is where we must be honest about the boundaries of what we know. This is where certainty ends, and where the real investigation begins. Poincaré's theorem requires a bounded system, a system in which particles cannot escape to infinity. A universe that is expanding and expanding acceleratingly may not satisfy this condition. If the universe is open, if particles can drift apart forever into an ever-expanding void, the recurrence theorem may not apply to the cosmos as a whole. This remains an open question in cosmology. There is no consensus. Some physicists argue that the de Sitter phase predicted by our current model creates conditions functionally equivalent to a bounded system, because the cosmic horizon confines the accessible degrees of freedom to a finite number. Others argue that the true number of degrees of freedom is not well defined in an accelerating universe. The debate continues. But consider what even the possibility means for you. The moment you are in right now. This specific neural state. The exact position of every atom in your body. The precise thought forming in your mind as you process this sentence. If the recurrence holds, this moment is not unique in the history of time. It is a configuration. And configurations in a system with infinite time are not unique. They are scheduled, not by any external force, not by destiny or design, simply by the arithmetic of a finite set of states in an unbounded duration. Every moment of suffering you have ever experienced, if the recurrence is real, is not a thing that happened once and ended. It is a coordinate that will be visited again. Every moment of joy, likewise. The past is not gone. It is pending, not behind you, ahead of you. Think about what this means for the most mundane moments of your life. Not the dramatic ones, the mundane ones. The Tuesday afternoon when nothing happened. The Sunday morning when you stayed in bed too long and felt guilty about it. The Wednesday evening when you cooked dinner alone and the kitchen was quiet and you noticed, just for a second, how strange it was to be a person standing in a room. If the recurrence holds, that Wednesday evening comes back. Not a version of it, that one. With the same pot on the same stove and the same light coming through the same window at the same angle. The same brief, forgettable, almost nothing moment that you barely registered the first time. It comes back, infinitely. The recurrence does not favor the dramatic. It does not select for significance. It repeats everything equally. The boring days come back as certainly as the extraordinary ones. The moments you would choose to relive come back alongside the moments you would give anything to forget. The recurrence has no taste. It has no editor. It replays the raw footage. All of it. Forever. Waiting at a distance measured in units of time so large that the numbers lose all intuitive meaning. But waiting nonetheless. That was layer 7. And now we reach the deepest layer. The floor beneath all the other floors. Because the infinite universe does not just repeat you and does not just replay every moment of your life. It contains something that makes every one of the previous 7 layers retroactively more disturbing. Layer 8 of 8. The unknowability clause. We can never confirm any of this. Everything in layers 1 through 7 may be true. Every word of it. The copies may exist right now, living your life in parallel, billions of light years beyond the edge of your bubble. The recurrence may be guaranteed by the mathematics of time. The Hubble tension may be pointing at new physics that rewrites our entire cosmological model. The Boltzmann brain problem may be a genuine threat to the reliability of your own consciousness. Every implication we have traced through this descent may be an accurate description of the reality you are living inside of right now. But we will never know. Not because we lack the instruments. Not because we lack the mathematics. Not because we lack the funding or the will or the cleverness. But because the structure of space-time itself places a hard, permanent physical wall between us and any evidence that could confirm or deny the infinite universe. The regions of space beyond our observable horizon are causally disconnected from us. This is a technical term with a devastating meaning. Causally disconnected means no signal, no particle, no force, no influence of any kind can cross from there to here, ever. The speed of light is not just a speed limit for matter. It is a speed limit for information. It determines the absolute boundary of knowability. And the accelerating expansion means that boundary is shrinking. Every year, more galaxies cross beyond our cosmic event horizon. More regions of space become permanently, irreversibly inaccessible. We are not approaching the answer. The answer is receding from us, faster than light, forever. There is a deeper way to understand why this wall exists. In physics, information cannot travel faster than light. This is not merely a practical limitation. It is a consequence of the structure of space-time itself, encoded in Einstein's equations. The speed of light is not just the speed of photons. It is the speed of causality, the speed at which one event can influence another, the speed at which anything can know about anything else. Now combine this with the accelerating expansion. The expansion is creating new space between us and distant regions faster than light can cross it. This means the expansion is outrunning causality itself. Information that exists beyond the cosmic event horizon is not just unreachable. It is causally disconnected. It cannot affect us. We cannot affect it. In the language of physics, it is outside our past and future light cones. It is as separated from us as a different universe would be, except it is the same universe, the same space-time, the same matter, the same physics, just unreachable by anything, forever. The accelerating expansion is not just moving galaxies away, it is severing the causal connections between regions of the cosmos. It is turning one universe into trillions of isolated bubbles, each one unaware of the others. Each one constructing its own picture of reality based on its own limited view. Each one convinced it sees the whole because it has no way to learn that it does not. You are in a sealed room. You have every instrument ever built, every telescope, every particle accelerator, every mathematical framework devised across the entire history of human thought. You have the Planck satellite data. You have the James Webb data. You have the complete works of Einstein and Hawking and Penrose and Tegmark and Carroll and every other mind that has ever grappled with these questions. Someone slides a note under the door that says, "The answer to the most important question you will ever ask is written on the other side of this wall." You spend your entire life measuring the wall, pressing sensors against it, calculating its thickness, its composition, its vibrational modes, its quantum properties. You confirm beyond any doubt that there is a wall. You confirm that it is getting further away. You cannot confirm what is on the other side. The wall does not open. This is not a limitation of your instruments. This is the design of the room. Physicists David Deutsch and Chiara Marletto, in their 2013 framework called constructor theory, have argued that the boundary between what is knowable and what is unknowable is itself a physical law. The laws of physics do not merely describe what happens. They also describe what is possible and what is impossible. And some facts about the universe are impossible to determine from within the universe. Not practically impossible, physically impossible, structurally, fundamentally, permanently impossible. The unknowability of the infinite cosmos is not a gap in human knowledge that will be filled by future generations with better equipment. It is a feature of space-time. It is a wall that physics built and physics cannot tear down. Think about what this wall means for every question you have ever asked about the universe. Is the universe infinite? We will never know. Do copies of you exist? We will never know. Does the recurrence hold? We will never know. Is dark energy constant or changing? We may learn something about this from D, ESI, and future surveys. But the full answer, the answer that requires sampling conditions beyond our horizon, is permanently inaccessible. Is the cosmological principle true? We assumed it. We cannot verify it. Is our observable universe typical or anomalous? We have no comparison sample. We have exactly one data point, our bubble, and no way to obtain a second one. Every conclusion we have drawn about the cosmos is based on a sample size of 1. And in statistics, a sample size of 1 tells you almost nothing about the population it was drawn from. The mathematician would say we are overfitting. We have built an elaborate model that perfectly describes our single observation. But we have no way to test whether the model generalizes. We are in the position of a scientist who has observed one swan and concluded that all swans are white. The black swans may exist by the billions beyond the horizon. We will never see them, and our model will remain forever a theory that perfectly fits the only data point we have without any guarantee that it fits any other. Let that settle for a moment. Not the theory, the feeling, the sensation of being an observer trapped inside a system whose most important questions are structurally unanswerable. You cannot leave the room. You cannot see past the wall. You cannot even trust that the room you are in is typical of rooms elsewhere, because you have no comparison. This is not a temporary condition that future generations will remedy. This is the permanent epistemic condition of any observer in an accelerating universe. Our descendants, no matter how advanced, will face the same wall, the same limitation, the same fundamental unknowability, and they will face it from inside a smaller visible universe than the one we see today, because the horizon will have retreated further by then. We are, in a very precise sense, the best positioned generation of observers that will ever exist. We see more of the cosmos than anyone who comes after us will ever see. And even we cannot see enough. Pull all 8 layers together and hold them in your mind for a moment. Every cosmological model, every law of physics derived from observation, every conclusion about the nature of reality was built from data collected inside a bubble that may be an infinitesimal fraction of the whole, during one of the rarest windows in cosmic time, in a universe whose fundamental expansion rate we cannot agree on, with a 5 sigma discrepancy that 2 flagship telescopes have now confirmed, using instruments that can reach only 6% of the galaxies that are already visible. And the answer to the most consequential question, whether all of this is finite or infinite, whether copies of you exist right now, whether moments recur eternally, is located beyond a wall that the laws of physics will not allow us to cross. The answer exists. We just cannot get to it. And the gap between us and the answer is growing. We have reached the bottom. The paradox is not resolved. The copies are a genuine mathematical consequence of premises that mainstream cosmology accepts. The recurrence is a genuine theorem proven by one of the greatest mathematicians in history. The Boltzmann brain problem is a genuine crisis acknowledged by some of the most respected physicists alive. The unknowability is a genuine structural feature of the space-time we inhabit. None of this is softened by what comes next, but it must be said, because there is something hiding inside the horror that the horror itself cannot see. If the universe requires infinite copies of you to exist, if your specific arrangement of atoms is so robust, so stable, so physically favored that the cosmos must repeat it across distances no number can describe, then what you are is not diluted by the copies. It is confirmed by them. Think about what repetition actually means in a physical universe. The cosmos had infinite space to fill. It had a finite alphabet of particles to fill it with. It could have produced anything. Infinite random noise. Infinite clouds of hydrogen that never collapse into anything structured. Infinite featureless void stretching outward forever. Instead, given the right conditions, which the same physics produces everywhere, it produced galaxies, stars, planets with liquid water, organic chemistry, nervous systems, brains capable of asking whether copies of themselves exist. The fact that your pattern recurs is not evidence that you are replaceable. It is evidence that you are necessary. Your configuration is so stable, so specific, so physically favored by the laws of matter and energy that the universe cannot help but produce it, again and again and again, across infinite space, without being asked. The copies do not diminish you. They are the universe voting for you with its own physics. And if every moment recurs, then here is what Nietzsche understood that most people miss when they first encounter the idea. The eternal recurrence is not a prison. It is a test. If every moment of your life will happen again, identically, infinitely, then the moments worth having are the moments worth repeating. The question is not whether you can escape the loop. You cannot. The question is whether you would choose it. Whether the life you are living right now is one you would willingly live again. And again. And again. Not as punishment, as confirmation, as proof that the shape of your life was worth the atoms it took to build it. That is not a cosmic horror. That is the most precise moral compass the universe has ever accidentally produced. Consider one more thing before we close. You did not choose to exist. You did not apply for consciousness. You did not select this particular moment in cosmic history, this particular planet, this particular body. You arrived here through a chain of physical events stretching back 13.8 billion years, none of which had you in mind, none of which were aimed at producing you, none of which cared whether you existed or not. The universe assembled you the way it assembles everything, through physics, through chemistry, through time and chance and the relentless operation of laws that do not know your name. And yet, here you are, conscious, asking questions about infinity, wondering whether copies of yourself exist in regions of space you will never see, feeling something right now that is unique to this specific configuration of atoms in this specific moment in the history of a cosmos that may contain infinite versions of everything, but has only ever produced one version of this exact feeling at this exact time. That is not nothing. In a universe of 10 to the 80th particles, in a cosmos that may extend infinitely in every direction. In a reality that may contain more copies of your neural pattern than there are stars in the sky. The fact that you are here, reading this, feeling this, wondering about all of it, is not a statistical inevitability to be dismissed. It is the universe doing the thing it is rarest at. Not burning hydrogen, that is easy. Not forming galaxies, that is common. But producing something that can look at the whole enterprise and ask whether it has happened before. That is the trick. That is the thing the cosmos almost never achieves. And you are it, right now. For however long right now lasts. Traffic jams do not matter when you are contemplating the paradox of infinite recurrence. Career anxieties do not matter when you are staring at the edge of knowability. Social hierarchies do not matter when your atoms are scheduled to reassemble across distances that require exponents of exponents to describe. What matters is the experience of being, the weight of a thought you have never had before, the warmth of another person in the room, the specific sound of rain on a window at 3 in the morning, the strange, unearnable, impossible privilege of being conscious in a cosmos that may be infinite, but that you, right here, right now, are experiencing for what feels like the first time. The universe may be infinite. It may contain infinite versions of you, in infinite galaxies, under infinite skies. But right now, in this specific room, in this specific moment, only one of those versions is hearing these words for the first time. And that first time, by definition, can never be repeated, not even by infinity. The experience of novelty, of encountering something you have never encountered before, is the one thing the infinite universe cannot duplicate across its copies, because the copy who hears it next will also be hearing it for the first time. From the inside, every encounter with the new is original. The cosmos may repeat the configuration of your atoms. It cannot repeat the feeling of the configuration being new to the mind inside it. You are the universe, looking at itself from the inside of a bubble it cannot see past, wondering what is on the other side. And the fact that you are wondering at all, the fact that a particular arrangement of atoms forged in dead stars and assembled by blind chemistry on a cooling rock orbiting a middle-aged sun, has achieved the capacity to ask whether copies of itself exist in the infinite reaches of a cosmos it will never be allowed to explore, may be the rarest and most significant thing the universe has ever produced. Not because it is unique in space, but because it is unique in perspective, your view of the cosmos from inside your particular bubble, in your particular moment, with your particular history and your particular capacity for awe, has never existed before. And even if the atoms reassemble, even if every proton and neutron and electron finds its way back to exactly this configuration, 10 to the 10 to the 118th meters from here, the moment of first discovery belongs to you. Every first time is real, even in a universe that repeats itself, even in a cosmos that copies everything. The feeling of now is yours. It always was. Here is one final thought. The paradox of the infinite universe is not actually about the universe. It is about you. It is about the fact that you are the one thing in the cosmos that the paradox cannot dissolve. The copies exist. The recurrence may hold. The unknowability is permanent. But the experience of existing right now in this configuration, with this specific quality of consciousness, is not diminished by any of it. It is the one irreducible fact that survives every layer of the descent. You can doubt the universe. You can doubt your memories. You can doubt the permanence of anything you have ever known. But you cannot doubt that something is experiencing this doubt. That experience is the fixed point around which the entire infinite cosmos rotates. Not because you are the center, but because experience is the only thing the universe has ever produced that can look at infinity and feel something about it. The stars do not feel the recurrence. The copies do not feel their multiplicity. The void beyond the horizon does not feel its own unknowability. Only you do. Only something arranged exactly the way you are arranged, right now, in this moment, can hold these ideas in mind and be moved by them. That capacity, the capacity to contemplate the infinite and be changed by the contemplation, is what makes the pattern worth repeating. The universe copies you, not because you are ordinary, but because you are the universe's way of knowing that it is extraordinary. And that knowledge, that single act of self-recognition through the medium of a conscious mind, may be the rarest event in the entire cosmos. Rarer than the formation of a star. Rarer than the emergence of life. Rarer than the survival of a civilization long enough to develop the mathematics of infinity. You are the cosmos, knowing itself. And for as long as that knowing lasts, nothing in the infinite void can take it from you. And so the paradox resolves, not in the mathematics, but in the experience. The mathematics says you are a repeating pattern. The mathematics says the copies exist. The mathematics says the moments may recur. But the mathematics cannot contain the feeling of being inside the pattern. The feeling of this moment. The feeling of now. That feeling is not a calculation. It is not a configuration. It is the thing the configuration produces when it reaches a certain threshold of complexity. It is what the universe does when it arranges matter just so. It lights up. And the light it produces is not photons. It is awareness. It is you. The universe may be infinite. It may repeat everything. But it does not know. It is infinite. It does not experience its own repetition. Only you do. Only something structured, exactly the way you are structured, can hold the concept of infinity and feel something about it. The universe produced the concept. You are the experience of the concept. And that distinction between producing and experiencing is the only distinction that matters in an infinite cosmos. Do me a small favor. It will not reach your copies in other Hubble volumes. But clicking that subscribe button will help the algorithm find the next observer in this one. I want to know which layer of this broke you the most. Was it the copies, the recurrence, or the fact that we can never know? Tell me in the comments. And if you want to keep exploring the terrifying beauty of what the cosmos reveals about who we are, make sure to subscribe. I will see you in the next one.